Welcome to today's e-showcase, Intelligent Water and Energy System Upgrades, the key to sustainable infrastructure renewal. I would like to take a second to thank our sponsor, ENGIE, for sponsoring today's event. Today's sponsors, today's presenters are Thomas Monter and Elaine Marshall. Thomas is the lead project engineer for ENGIE North America, and Elaine is the Deputy Public Works Director for the City of Milpitas. With that being said, I will hand the presentation over to our presenters, and we hope you guys enjoy today.
Great, thank you. Good morning, everyone, or actually good afternoon, depending on where you are. Again, my name is Elaine Marshall. I'm joined here with Thomas Monter. We're excited to present and talk about a project that we've been working on for, gosh, for me going on over 4 years since the inception, but really with focused implementation during the last 2 to 2.5 years. I will go ahead and get started. For our agenda today, we'll talk about the growing need to connect and automate our water systems. I'll provide a quick overview of our full smart city infrastructure program, and then Thomas will do a deep dive into our SCADA and our water automation initiatives and focus with savings and ease of operation for our operators. And then we'll have time for Q&A. So the growing need to connect and automate our water systems, and for Milpitas, really all of our infrastructure. We were looking at a challenge and looking at our systems, which were mostly manual and analog, and really wanting to take the initiative and move our operations in a more smart direction and utilize technology in a better way to better monitor our operations, as well as being able to better connect our operations with our staff, as well as with our community. I know we all faced common challenges, whether you're with a local government or with a private utility. We have elected officials, city councils, boards that we need to report to and that hold us accountable for operating our utilities and our operations in a sustainable, cost-effective manner. We also have competing challenges with maintaining a high customer satisfaction and really demonstrating the value to our community for the cost of our infrastructure investments. Most of the time, our community members, our customers, don't want to think about a lot of our services. They want the water to run. When they turn on the tap, they want to be able to have things move down their drains, down their toilets, without having to think about it. It's actually when they think about it that things become an issue. And so really needing to make a great business case for investing in these improvements in operations that they really don't want to think about too much, but really wanting to take our systems to the next level, as well as really needing to manage our operations with less resources and become more efficient. And then at the same time, we're also all responding to changes in climate, changes in weather pattern, and really needing to be more agile in how, as an organization, we respond to those needs, to larger storm events, as well as even increasing drought conditions, things that we've seen here in California in the last couple of years. Just a little bit of context on where the city of Milpitas is. We are located in California, as I mentioned, in the northern part of California, about 45 miles south of San Francisco. We have a population a little bit over 80,000 and a land area a little bit over 13 square miles. We're a full service city. We have police, fire operations, parks and recreation services, as well as full public works operations. I'm the Deputy Director for Public Works. I oversee our environmental utility operations and maintenance programs, as well as our sustainability, environmental compliance, as well as our just administrative and strategic support for the entire department. Our water system, just a quick glance at our water system. By the numbers, we operate a water distribution system that serves all of our residents and commercial and industrial customers. We have approximately 16,750 customer accounts, delivering 8.3 million gallons of water per day. We have actually two different water types. We distribute potable water as well as recycled water or reclaimed water. The reclaimed water system is used mostly for outdoor irrigation, as well as some of our cooling towers and commercial businesses. We have two sources of potable water. We get our water from the San Francisco Public Utilities Commission, or the Hetch Hetchy system, as well as from the Santa Clara Valley Water District. We maintain over 200 miles of underground water pipe, 5 water tanks and reservoirs, 4 pump stations, and 17 pressure reducing valves throughout our system. On the sewer side, we maintain our sanitary sewer collection system, which consists of 175 miles of sewer pipe, 5 miles of force main pipes that deliver our sanitary sewage to a regional treatment facility. We have 2 pump stations. We clean over 90 miles of pipe every year. We have over 3,000 manholes, and again, over 15,000 accounts, and serving our population of over 80,000. On the stormwater side, I don't have a slide, but same thing. We have a system that consists of 13 stormwater pump stations, as well as almost 200 miles of storm pipe, and over several hundred storm drain inlets throughout the city. So I'm going to dive a little bit deeper into and go over our full suite and portfolio of our Smart City Infrastructure Program. Back in, I think 2019, the city began looking at a comprehensive water and energy system upgrade throughout our city operations. It was actually more expansive than just our water or our utility operations. It included looking at lighting throughout our community, our city facilities, as well as our parks and our street lighting, as well as water features, fixtures throughout our facilities. The city actually went through a competitive process. We issued an RFP for this comprehensive service, which included a full investment grade audit of water and energy systems and efficiency measures and savings estimates. In the end of that RFP process, the city selected and contracted with ENGIE for the investment grade audit, as well as the next phase of implementation. Our program consisted of up to 10 different measures that covered advanced water infrastructure, energy lighting upgrades, as well as energy resiliency. Together, these measures reduced our electricity consumption throughout the city by more than 4.2 kilowatt hours per year. We are estimating and hoping to generate $50 million in lifetime savings over this entire project. And really that helped us meet our climate action goals, as well as really looking at how we modernize and go from an analog-based operations to a digital and a smart based operations for all of our public works operations. Really, one of the benefits of going this direction for us as well was that we have a very small staff, and working with ENGIE as our partner and primary contractor, we were able to leverage additional resources to really kind of carry out a lot of these changes. I don't think there would be any way we would have been able to implement this on our own. We also were provided with a community engagement and communication support, including a fellow that came on board to help really kind of look at how and help us present these program elements in a great context for our community. Really wanted to demonstrate how the city was leading by example here, and that all of the changes that we were making, whether it was energy efficiency, water efficiency, these and solar or backup batteries, these were really opportunities for the community to learn from what the city was doing and even implement these actions in their own homes. So we had a fellow that was really helping with that communication aspect and community engagement. The cost of the program was offset by mostly by the savings that we were anticipating on our utility side, as well as we were able to work with ENGIE and other local partners and leveraged quite a bit of grant funding for various components of this project. One of the biggest and most visible pieces of this project was really turning our senior center and community center into resiliency centers for our community. With this project, we were able to install solar PV as well as backup battery and microgrids at both of those facilities. This will allow us to continue to power these facilities in case of power outages, public safety power shutdowns here in California were pretty prevalent in the last few years. And so we really wanted to be able to ensure and provide for our community a resilience center where they could come to, whether it was a cooling center, a recharge facility. We are proud that we were able to keep these facilities operating when there is power outage throughout the rest of the area. So this system for each of these facilities consisted of, as I said, the solar carports or solar panels on the roof, battery energy storage, as well as kind of a third backup natural gas generator, or in one case, a diesel generator, so that we are able to, again, just provide ongoing electricity and power for those facilities. We also took the opportunity to install electric vehicle charging stations associated with these systems as well. The other component of the project included lighting infrastructure improvements. We replaced older generation lamps with LED fixtures throughout our parks facilities, including nighttime tennis courts and other sports fields. We also upgraded all of our street lights to LED and added monitoring nodes to all of our street lights. So we now also have these street lights tied into an outage detection system. And so we are able to actually just get alerts when street lights are not working, as opposed to being reactive and waiting for our residents to call in and let us know a street light's out. We're now able to monitor on our web-based platform whether or not the street lights are functioning and turning on and off as they should, as well as the power output. And now I'm going to get to our water system infrastructure improvements. Through this project, we installed over 15,000 advanced metering infrastructure meters with leak detection for our customers. We also went and installed and upgraded all of our controls and implemented a SCADA system at our water, stormwater, and wastewater pump stations and facilities. Tom will dive into the details of that project later on in this presentation. We also installed new pumps and automated treatment systems for our water supply facilities. which allowed us to provide for longer storage and reduce the amount of water waste throughout our operations. And then on at the other city facilities like City Hall, Community Center, and Senior Center, we also installed water efficient fixtures. We took the opportunity with the pandemic to go touchless with these fixture upgrades as well, which was, I think, beneficial during the last few years. So our citywide AMI component of this project, most of our meters were beyond the manufacturer's recommended life. They were more than 20 years old through this project. We replaced them all with AMI technology. This really helped us with improving our billing accuracy. In some cases, for some water accounts, we were not able to read the meters, and we were billing based on estimates. So really, this upgrade helped tremendously in improving our billing accuracy, as well as reducing the need for our manual meter reads or radio-based meter reads. And so we are becoming more efficient with our operations since we've converted to AMI technology. The water information is transmitted automatically to our system, as well as then integrated with our billing system. We also are able to provide our customers with more timely information. I'll show you in our next slide. We're able to, with AMI technology, introduce a customer-facing system for them to monitor and track near real-time water use. They're able to sign up for leak alerts and other high use notifications. And then they're also able to get customized water conservation recommendations, as well as we're able to push out information and messaging for water conservation rebates and incentives. This really does put more data in the hands of not just us as a utility, but also our customers, and so they have a better sense of water use in their homes and what impacts water saving actions can have on their water use. Okay, I'm going to go ahead and turn it over to Tom, who will do a deep dive into our SCADA component of the project.
Thanks, Elaine. The SCADA system, which stands for Supervisory Control and Data Acquisition, that we installed in Milpitas, was an inductive automation's ignition-based platform. We did a pretty detailed analysis of several different platforms in combination with Milpitas staff to select a platform. And because of the wide area network capabilities of ignition and the ability to add multiple sites later on as the system expanded, that was the platform of choice for this project. One of the benefits of this SCADA system is that we were able to integrate multiple systems for control and monitoring. Everything from water treatment, pumping, wastewater, stormwater, and we do also have some pressure zone adjustments and monitoring as part of a later phase of this project. Also, additionally, the SCADA system that we chose has the ability to integrate some of the other subsystems like the smart water meters, lighting, building controls, and other city functions using open APIs. That isn't something that has been performed yet, but it is an option for the city at a later date, and could offer benefits in terms of being able to monitor the system remotely and keep track of active alarms for the entire system. The pictures on your right, the top one is an overview of the water and stormwater and wastewater lift stations. When those are in alarm, they will actually show up as active alarms, and the city can go in and see this dashboard and just view exactly what's taking place at each of those sites. And if they click onto those sites, they can get an overview of each of those sites. And the bottom screen there is a summary of their 3 sites that sit up on top of a hillside in Milpitas there that are all tied together and and shows just sort of a general overview of how they monitor those tank and pump systems at those hillside sites, and allows them to really get an overview that they weren't able to before. Their previous staffing issues were that because they are a small city, relatively speaking, with a very small staff, they were spending a lot of time sending staff off to alarm calls, which are all dispatched through their PD system via telephone. And so anytime there was an alarm, they had no way to understand what the status of that alarm actually was. They would just have to visit the site and find out what the cause was. So this allows them to monitor those sites remotely and see what the alarm is. And if it's not critical, they don't necessarily have to take staff off of something else important in order to visit those sites. Next slide. One of the primary reviews that ENGIE did was to look at all of the city's pumping systems and figure out where there were potential savings based on pump performance and pump age. So we did an audit of all their pump systems and found a handful that offered some energy savings, but also solved some of the city's problems with their aging infrastructure. As I'm sure most people on this webinar are aware, that a lot of the infrastructure around the country is aging. Pumps are one of those that often are overlooked because even though they're operating, they're not very efficient. And so we went in and checked out all their pump systems and found several that were not only not very efficient, but they were having problems finding parts for those pumps as they aged out. So what we proposed was to replace a couple of the pumps where they had sites where there was two pumps, a primary and a backup, and we replaced those with newer vertical turbine pumps that allowed for easier maintenance and more efficiency, and of course modernized the equipment and allowed to do some more advanced monitoring with the new pump designs. In the picture in the back, that pump in the front, that is one of the new vertical turbines, and the pump in the rear is actually one of the old submersible pump designs. There's a pretty large efficiency improvement by moving from that submersible to that vertical turbine. Next slide. The water treatment system at Milpitas had a lot of challenges just because there was really no way to monitor these sites remotely. They were having to send up staff multiple times a week to monitor water quality. Especially during the summer, they would run into problems with bacterial growth for nitrifying bacteria in their tanks when the water temperature got warm, because they're using monochloramines at the site there. And chlorine also offers issues during high temperatures, but a different set of issues. But what we found is that because those tanks were not actively mixed with the mixer in the tank, and because there was no automated dosing, they were having to turn the water over in the tanks fairly frequently in order to maintain that water quality. And what ENGIE had proposed to do was to install new tank mixers and new automated treatment systems to maintain their residual levels in their tanks. And that would also allow them to store the water in the tanks longer periods without having the water quality degradation and having to turn that water over. So it saves them a lot of water for getting wasted, and it also saves a lot of pumping power in order to maintain the water quality in those tanks. And in addition to that, we were able to integrate all those tank systems into the new SCADA system, and they can actually monitor the water quality and monitor tank levels and understand all the facets of the tank operation of those reservoir sites. So it's been a great improvement to the city being able to monitor systems, and if they get an alarm now, they don't necessarily have to immediately go up to the site and take a look at the system. They can just decide whether or not that a call is necessary at that time. Next slide. Water treatment, the upgrade benefits. One of the biggest issues with all all cities and all municipalities is that reporting is always one of the primary goals of the city. And compliance is pretty much, when it comes to operations, the most important part of city operations. If you can't remain in compliance, really none of the other things matter, because that faces not only problems with your water quality, where your residents cannot drink or utilize the water, but it also runs the risk of regulatory fines. And so one of the goals of this was to make better compliance for the city's water quality, also improve the accuracy of the reporting so that they can keep an eye on what water quality does over time. And it reduced their risks with the State Water Resources Control Board of having any potential fines if something gets out of compliance, because they can head those compliance issues off before they happen. The controls, they were able to offer more precise controls over the water systems, as we talked about earlier, better treatment and pumping in their stormwater systems, and better control over their overall distribution systems. They can monitor each of these systems individually and as a whole, and make sure that if problems arise, they can find those out sooner rather than later, which of course makes it easier on their staff. Monitoring, they can now train their staff to other problems in the city that aren't necessarily spending all their time visiting all of the various sites. As you can see on the previous map, there's a couple dozen sites they have to visit, and it also has reduced their chemical cost usages at those sites, where the amount of chemical they use is just enough to maintain their residual levels, and they're not having to spend additional chemical to shock the system if they have problems with water quality, especially during summer months. Next slide. For the automated tank mixing and dosing, the residual controls for this, the curve on the right is a chloramine degradation curve. And when temperatures are high, what you see is that the chloramine will degrade and you'll get ammonia formation in the tank. And then that free ammonia that is present in the water will promote the growth of nitrifying bacteria, which causes a problem with the water quality in the tank. And so what these new tank mixing systems do is they add just enough chlorine or a little bit of ammonia to take up free chlorine to make sure that those monochloramine levels remain at their set points, even during high temperatures, where under normal conditions without the boosting systems, you would see a quality degradation and the formation of those nitrifying bacteria. This has really allowed the city to maintain water quality in their tanks, particularly their larger tanks at the sites. They can now leave water in those tanks for 2 to 3 weeks rather than the 3 to 4 days that they were having to previously. And then the SCADA allows to monitor each of those systems. Of course, SCADA in this case only monitors those local control systems because of risks. I'm sure everybody has heard of the problems that have taken place with cybersecurity attacks, and that was one of the primary goals of the SCADA system, was to make sure that the subsystems at the city were not vulnerable to those type of attacks. So this is a monitor-only situation where those changes to those systems cannot be done from a remote location. They have to be done locally. Next slide. This is the stormwater site retrofit. We took a look at all their stormwaters. The original panel on your left is your old relay-based controls, really from the 70s and early 80s. This is back in the days where controls were very, very expensive, and energy was and fuel was relatively inexpensive. And so this was fairly typical, is that advanced controls were really not added to stations like this. They were all done based on relays because it was a lot less expensive at the time. And the engines on the right are Caterpillar engines. When we started this project, we actually went to the OEM and asked if they offered upgrades to the controls on these engine packages. And unfortunately, as with a lot of OEMs, the OEMs are more interested in selling new engines rather than upgrading controls. And so we had to work with several different companies to find somebody that had experience upgrading the relay-based controls on this to these new Murphy controllers, which control each of those engines individually. These engines are actually all tied into the SCADA system as well. So you have a two-layer of control. The Murphy controllers control the individual engines, and the SCADA monitors the status of those Murphy controllers and reports the operations of each of those engines to the SCADA for the operators to view and plant staff to monitor. Next slide. This is an overview of one of the SCADA screens for the site. This is their Jurgen site. It's located at a park. It's got 4 engines. It's actually one of their more critical sites that they've had some flooding issues in the past. And what this system does is it automatically gives them an overview of what's going on with each of those engines. If there's a problem, of course, it'll show up on here. And then it also operates a small jockey pump to keep the wet well level down low during drier months. And the SCADA system actually controls the operation of all those pumps based on the wet well levels and monitors all the engine pump driven parameters there. Next slide. So as part of the designing the smart infrastructure initiatives, we had to focus on the savings and ease of operation for the city of Milpitas. Next slide. Of course, when we start with energy, we of course focus on cost reduction. That is always one of the biggest focuses for cities with shrinking budgets and expanding need for services. And so cost reduction, of course, is always the primary goal, but then climate action was also a big deal for the city of Milpitas, being that they're experiencing the PSPS events, fires, a lot of the disruptions caused by climate change, that being able to reduce their footprint and show that they're making some progress in meeting the goals for reduced carbon emissions was a big portion of this. And then, of course, the technology integration, as with a lot of municipalities, the infrastructure has really been ignored over the years, just because it's sort of an out of sight, out of mind platform. And so one of the goals was to be able to integrate all of these systems that have not been taken into account when it comes to technology rollout, and integrate those into this single platform. And then maybe Elaine can speak to this. Like community development is a big portion of this project, where we are collaborating with all of the parts of the community so that they can see the benefits of the system as it rolls out. Smart infrastructure solutions, of course, this system included all the different parts of this project. PV and e-mobility, adding vehicle charging at several locations in the city, building efficiency and automation, energy storage and microgrid resiliency, street lighting, and then of course the water and wastewater systems. And the SCADA eventually, hopefully, will play in a part to this, where all of those systems will be monitored by a single system, rather than having to track all those systems on multiple platforms. And next slide. One of the benefits of bundling projects when we do a project like this is that a lot of times parts of the project that wouldn't necessarily offer good paybacks but are pain points for the city can be performed, because some of the other parts of the project that do offer more savings allow additional funding to cover those pain points. And that was really the case with a lot of the stormwater sites, is that because of some of the savings in the other areas, and how the city was operating those sites, we were able to integrate a lot of those sites into the new SCADA system using savings from other parts of the project, which was a big deal to the city just because they were spending a lot of time monitoring all those stormwater sites, particularly during rain events and flooding events that have happened in the past. And so the goal was to make sure that they were able to maintain all those sites with their small staff that they have now. There's more incentives available when you bundle a lot of these projects together. You can get a lot of solar and other incentive packages that are available. And then you do get deployment efficiency by covering all these things with deferred maintenance, fewer disruptions of operations by teaming these sites to happen all at the same time. And then, of course, the community gets to see a lot of these other pieces that are more visible, that unlike the water and stormwater infrastructure, those are really kind of an out of sight, out of mind. Whereas a lot of these other pieces like the solar and the building improvements get to be seen by the public. And then this just covers our comprehensive approach that ENGIE comes in to support a city. We do a thorough assessment of all portions of the city's infrastructure, including buildings, lighting, water, wastewater, stormwater, and then we pick a solution package that, of course, that meets the goals of the city and hopefully fixes some of their more pressing issues, and do a financial analysis, try to find out what incentives and what savings will help pay for the project. And then really, in terms of the stakeholders, we make sure that everybody is engaged in the process and that we are making sure that we cover all the needed items that the city and municipality wants to address. And of course, we go through our implementation and operations as the project progresses. And I don't know if there's anything else, Elaine, that you wanted to discuss on this. Okay, and I think that's it. There's questions.
Awesome. So we have a question from Jim Decker, right? And the question is do we assume correctly that besides new pumps, you have the pumps controlled by variable frequency drives rather than soft starter or direct online?
In this case, the pumps that we installed do not have VFDs because they are actually operating in an on-off manner because they pump to reservoirs. So they're actually boosting water from the distribution system up to the reservoirs. So there's really no need for a VFD. In this case, they are just across the line starters. But there was a discussion about the soft starters, but because the pumps run relatively infrequently compared to some other pumps in the system, there was no need to add VFDs.
Gotcha. So another question that Jim poses is, are you also monitoring the VSD status and displaying for the central operations or monitoring sensors only?
I'm not sure what he means by VSD status. Can he?
Sure. Jim, would you elaborate a little bit further in the chat for us? Meanwhile, we have another question, and it is, what goes into an infrastructure audit?
That is basically, we will look at all of the various subsystems of the city. We have experts in lighting, in the various building controls, building envelope, and then for the stormwater, wastewater, and water systems, we walk through each of those systems, understand which equipment they have, and gather data for all that operating equipment to understand how the system operates. And then we take that data back and we look at all those subsystems and see how those operations can be improved and where there's energy savings opportunities based on the operations of those equipment.
Got it. Got it. So we have another question, and the question is, does Milpitas have plans to integrate more systems into the SCADA platform?
Sure, great question. We are looking at opportunities for expanding the SCADA. As Tom mentioned, right now the SCADA deployment is focused on our pump stations, reservoirs, and facilities. We will be exploring expansion to include our pressure reducing stations and pressure zones throughout the city and adding that to SCADA. We also have, outside of this ignition platform, smart covers on some of our sanitary sewer manholes. Those smart covers monitor and gauge the flow of sanitary waste throughout our system and alert us if it starts to rise, and so that we can respond and prevent sanitary sewer overflows. So we are looking at down the line whether or not there's opportunities to kind of integrate those into a single platform.
Got it. Got it. Thomas, I think Jim provided a little bit more clarity on his question. The VFD, variable frequency drive, can provide its status on communication networks. Is your central command display that you showed early on in the presentation showing the VFD status to the operator, or is the display only showing the sensors?
The display, we do have a couple sites with pumps that have VFDs, and the system will show the operation of those pumps and the VFD, whether it's start, stop, and of course, what percentage that VFD is running at. So that is something that is monitored through SCADA.
Got it. Got it. So guys, I think we have time for one more question, right? And I believe this is in reference to the Milpitas plans to integrate, right? For a broad program such as that, what was collaboration across teams and organizations like?
Oh, yeah, that's a great question because this project did touch on multiple divisions within our operations as well as other departments. We did have lots of communications and coordination meetings early on in the project as we were rolling out various components. We also had kind of a weekly status newsletter that provided updates on where we were, where ENGIE and the project was going to be working, whether it was at the community center, retrofitting lights, or at City Hall, retrofitting water fixtures, or even at our parks. And so really we were kind of all hands on deck trying to make sure that everyone was aware of project implementation and making sure that not only did we know, but then that the community was aware if certain facilities were not going to be available. We did also try to coordinate so that those changes would happen during non-operating hours, and so we were minimizing any impact to our community services. I think one of the timing is what was key. We were able to do a lot of the lighting fixture upgrades and water fixture upgrades at our facilities during the pandemic shutdown, and so that provided a great opportunity for the project staff to just kind of go in and wholesale make the changes because we didn't have to worry about anyone in the facility.
Got it. Got it. Well, guys, I think we are right at time. Do you guys have any final thoughts for our audience before we close for today? Great. Well, I want to take the time to thank Elaine and Thomas for a great presentation, and a special thank you to ENGIE for sponsoring today's event. This concludes today's e-showcase, and we thank you all for attending. The recording will be available at wefbuyersguide.wef.org. We will send all registrants an email tomorrow with that link. Please be sure to visit our event calendar to sign up for future events, and we hope you all have an awesome day. Goodbye.